video I'll be explaining question 2 of homework 11. So the question states that it is suggested that the following functions of v, which are given as f of v e raised to power minus mod of v, f of v equals to sine square v by v square, and f of v equals to 1 for mod of v less than equal to alpha, 0 for mod of v greater than alpha, which is basically represented by this plot. So these three may represent an autocorrelation function of a wide-sense stationary stochastic process by setting v equals to tau, or a spectral density function by setting v equals to omega, or both, which functions f of v may represent either or both. So basically we need to tell that if f of v can represent an autocorrelation function or a spectral density function, or both of them, or neither of them. So we know that if r of tau is autocorrelation function of a real wide-sense stationary stochastic process x of tau, then it should be even, and r of tau should be less than equal to r of 0. And the third thing is its Fourier transform is non-negative. And we also know that if the spectral density S of omega is a power spectrum of wide-sense stationary process x of tau, then it is x of t, then it is it should be non-negative. Now for the first part, f of v is given as e raised to power minus mod of v, and so first thing we see that this is an even function. So if we replace v with minus v, it will be same, e raised to power minus mod of v. And the second thing is e raised to power minus mod of v is always less than equal to e raised to power minus 0, which is basically 1. So e raised to power minus v will always be less than equal to 1. So it satisfies this condition. The third thing is its Fourier transform is given by 2 alpha upon alpha square plus omega square, which is non-negative. So this condition is satisfied as well. So this represents an autocorrelation function. Now for the power spectrum, we need to check that it is non-negative. So e raised to power minus mod of v, we always know, since it is an exponential function, it will always be greater than or equal to 0. So it also satisfies this condition and it represents a power spectrum. Now moving on to the second part, f of v is given as sine square v by v square, and if we see this is an even function, if we replace v with minus v, it's sine square v by v square again, so it's an even function. Now if we check if this satisfies this condition or not, so we'll take sine square tau by tau square, and should be less than equal to sine square tau by tau square, limit tau tends to 0. So we know that this limit comes out to be 1. So basically this condition is satisfied. And for the third condition, Fourier transform, if we find the Fourier transform of this term, it will come out to be as what we see on the plot, and clearly this is non-negative. So yeah, the function satisfies all the three criteria for autocorrelation. So yeah, it may represent an autocorrelation function. Now again for the power spectrum, this is non-negative clearly, so this definitely represents a power spectrum. Moving on to the third part, we are given that f of v is equal to 1 for mod of v less than equal to alpha and 0 for mod of v greater than alpha. Now if we take the Fourier transform of this, it is 2 sine alpha omega by omega, and as we know sine of alpha omega is can be negative, so this term is uh, so so this term can be negative, and therefore uh, this does not satisfy the autocorrelation criteria, therefore it cannot represent an autocorrelation function. Now for the power spectral density, we can always see that f of omega is always non-negative, as we see from the values given. So yeah, this represents a power spectrum, and this function represents a power spectrum. So yeah, with this this was the end of the uh, homework 11 question 2.